So the purpose of optimization, why do we want to do optimization? Or what is optimization? So the purpose of optimization is to minimize the surface area, which means when you minimize the surface area, what would you be doing?
Minimize the cost.
Minimize the cost, right? Minimize the material you're going to use, right? And optimize, which is maximize the volume. And we said that when we are dealing with rectangular prisms, the optimal dimension will always be that of a cube. Now, in our formula sheets, we only have the surface area or the volume of a rectangular prism, right? And then it's length times width times height when it comes to the volume, right? And then when it comes to the surface area, it's 2 times the area of each side added up, right? So now, when it comes to a cube, instead of writing length, width, and height, I can replace the length and the width and the height with the same letter, right? Because they're all the same length. I don't need length, width, and height. They're all the same size. So I can use the same letter for all of them. We're using the letter S here just because the formulas are using S. You can use whatever letter you want. A, S, B, whatever you want, right? They're using S for the side. So because it's a cube, then my length is S, my width is S, and my height is S. So then I don't have to use the formula of length times width times height anymore. Because length and width and height are all S's. What would that give me? S times S, which is S cubed. S cubed. Sorry, right? It's okay. I got it. Right? So when it comes to a cube, your formula is S cubed. Right? Now, if I'm looking at the surface area of a cube, so I have my cube here, right? The area of one side is S times S, which is S squared, right? The area of one side, you okay with that? S squared. Now all the sides are equal, and I have 6 sides. So that makes the formula 6S squared. Right? Do we understand where these formulas are coming from? Do we understand that? Okay? So, since the length, width, and height of a cube are all the same, we refer to all the sides as the letter S, and then the formulas become surface area is 6S squared, and the volume is S cubed. Now, when you're optimizing rectangular prism, you want to use these formulas. Okay? You want to use the 6S squared and the S cubed for the volume. All right? Now let's see, when do I use these? Again, all these questions might not make sense in real world scenarios, right? Ignore that they don't make sense and just go with the question, please. The volume of a shoebox is 5,000 centimeter cubed. Calculate the optimal dimension of the prism. Now, your keywords that you're looking for are optimal, minimum, maximum. You're looking for these. When you read this, then you're going to think about optimization. Is that clear? So, because I have that word here, optimal, then I know I am looking to optimize. Now, what am I optimizing since they give me the volume? So what am I optimizing? They gave me the volume. I only have one thing to optimize. What is it? The surface area, because the volume is given to me, right? So I'm optimizing the surface area. I want the dimension that gives me the best surface area, which is the minimum in this case. Now, So I'm looking for the dimension. I'm just gonna write this one time so you know what I'm thinking when you read it. So I'm looking for the dimensions. I will not be writing this for every single question. That gives me the optimal, which means in this case the minimum, right? Surface area. Now, how can I find this dimension given the volume? Where do you want to start?
Like finding the total of 5,000
Where would you want to plug it?
in the volume.
Yeah. Because they gave me the volume, I have to use the volume formula, right? So what's my volume formula for cube? I know the shape has to be a cube, right? Because that's my optimal shape. So the volume formula, because they give me the volume, I have to start with the volume formula. Okay? So my volume is S cubed, and I know that my volume is 5,000. And what am I looking for? Side length, S. Right? How do I find that? Cube root it. Exactly. Right? So when I cube root this, right, that gives me, what's a cube root of 5,000? 17.1. So my optimal shape, or my optimal surface area, right? Let me rephrase that. The dimension that's going to give me the optimal surface area is 17.1 by 17.1 by 17.1 centimeters. Thank you. All right? Now, what kind of, like if I want to give you a part B to this, I want to give you a B question. What do you think I should ask you?
The opposite way.
I can't give you the opposite way because I'm starting with a volume. What do you think? What kind of question I can ask you here? Find the minimum surface area, right? I can ask you to find the surface area. Right? And then it's a matter of just taking this formula, right? Plugging in S as 17.1 and find your surface area. And that would be your minimum surface area. Right? That could be part B. Are we okay with this? All right. Now let's look at the second question. The surface area, there is other than the question itself, there is a mistake in that question. Can you find it? Other than the question itself.
This one area and they put the cube.
The cube,
Yeah. So it should be what?
the volume square.
It should be centimeters. So the surface area of a pizza box is 45,000 centimeters squared. Find the dimensions of the optimal pizza box. Again, your keyword here is optimal. Other than that, we're doing the optimal optimization. So what would you want me to do here? Where would we start?
Plug in the surface area formula.
So start with the surface area formula. Now the surface area is equal to 6s squared. We know that our optimal shape is a cube, and then that's going to be 45,000. And then what do you want to do then?
Divide by 6.
Divide by 6 first, yep,
And then square root.
and then square root. Perfect. So what's 45,000 divided by 6?
7,500.
7,500.
86.6.
And then you got yourself, I don't know what shape pizza. A fun one. All right, so therefore, the optimal dimension are 86.6 centimeter by 86.6 centimeter by 86.6. And the addition to this question would be find the optimal volume, right? If I want to add to this, I can ask you, what's the optimal volume of this shape, of this box? Remember, you're like for you because we're gonna do more than what is it called? Rectangular prism, right? We're gonna look at cylinders as well, right? So you're gonna have to think about what is the shape because in this case, when it says a box, you know it's gonna be a rectangular prism, which makes it a cube, right? If it says a can, you're hoping it's a cylinder, right? Can you have a square can? I don't know.
Never seen one.
Never seen one.
Yeah, we'll change the name of Ken.
Yeah. Change the name. All right. Are we good with this? Yep. Why am I putting it 3 times? Because when we're talking about dimension of a cube, you need the length, the width, and the height, right? A dimension of any rectangular prism, or when they give you the dimension, they give you 3 things, right? Length, width, and height. So that's why I'm putting it 3 times. Are we good with that?
No, but
All right, to the more fun part. Okay, so we understand that a cube gives you the optimal shape, right? Now, when it comes to a cylinder, to make it kind of similar to a cube, they make the optimal shape, and if you want, you can test that. You can find different shapes and then test it. But the optimal shape is the one that your diameter is equal to your height. Okay? That's going to give you your optimal shape. So when your diameter is equal to your height, okay? That gives you the optimal shape. Now, but our formulas don't deal with diameter. Our formulas deal with radius, right? If you go back to the cylinder formula, right? It's 2 pi r squared plus pi r h or 2 pi r. I can't remember. What is the formula for a cylinder surface area? 2 pi r squared plus pi r
2 pi r squared plus 2 pi r
2 pi r h, and then I said that, right? And then the volume is pi r squared h. So we deal with the radius, we don't deal with the diameter. Okay? So instead of writing that the diameter is equal to the height or the height is equal to the diameter, we write that the height is equal to 2r, right? Because we know the diameter is twice the radius. Yes? Are we okay with that?
Shouldn't we just write D?
Huh?
Shouldn't we just write D then?
Can you just write d, but then how are you going to change the formulas?
Just 'cause
then you're gonna have fractions. You want fractions? Okay, then do it. All right. Now, let's recall the surface area of a regular cylinder. Not the optimal one. So what's the surface area? It's 2 pi r squared plus 2 pi r h. And the volume is? Now, because we're looking for the optimal shape, then we know that we want the height to be twice the radius, right? We want that. So now what happens is we're going to change the height in the formula. We're going to replace the height with twice the radius. Okay? So we can look for the optimal shape. So we can look for the optimal form. So if we do that, we get this. 2 pi r squared plus 2 pi r times 2r. So that's going to be 2 pi r squared plus 4 pi r squared, right? Are you guys okay with that? 2 times 2 is 4. Pi r times r is r squared. Are we okay with that? So 2 pi r squared plus 4 pi r squared. Can I leave it like this? Can I change it? What do I do? Add it, right? You have 2 pi r squared plus 4 pi r squared gives you 6 pi r squared. Right? So instead of using this formula that has radius and height, now I have a formula that will only have the radius in it. You guys see that? You see that now the surface area of the optimal shape only has the radius. Why do I only want the radius? Because then I can isolate. If I know the surface area, I can find the radius. And then once I find the radius, I'll deal with the height. Okay? Now I have to do the same thing with the volume. So I'm going to replace h with 2r. And that's going to give me 2 pi r cubed. So the optimal cylindrical volume is 2 pi r cubed. The optimal cylindrical surface area is 6 pi r squared. Are we okay with this? Yes? Which formula sheet? For what? We don't have a test. We only have an assignment. So that's a good thing. It's an open book,
It's
right?
gonna be hard, I think.
I don't think so. Yes. Happy Valentine's Day.
Yeah.
And that's why I made it assignment, because I love you guys so much. I don't want to give you a test. Yes. I put it on a red paper too. With a piece of chocolate. All right. Here is a question. So the surface area of a can, you see now the question's changing to a can instead of a box. Of a can of soup is 154.6 centimeters squared. Find the optimal dimension of the can. Again, what's given to me? So what formula do I have to start with? So I have to start with the surface area. How do I know I'm optimizing? Because you have the word optimal. Thank you. All right. So what do I have to do now?
Yeah, no, divide by 6 pi.
Divide by 6 pi. Right? You can do it step by step, divide by 6 first, then divide by pi. Or you can divide by 6 pi altogether. Now when you do that, make sure you put it in brackets. I don't have my calculator here. Eight point two, and then that's r squared.
Where was it?
2.8.
So what is it?
2.86.
So 2.9? I don't know, whatever, 2.86. All right, whatever.
So you just go into two.
Two decimals is fine. There's no rules for this one. Usually, if your answer is to one decimal place, you have to just use this one decimal place. I won't be picky at this unless I specify. Yeah. So I found the radius, but that won't be it. That's not how I'm gonna have to find the height, right? Because remember, a cylinder has a radius and a height. Okay. So to find the height, it's a matter of just h is equal to 2r, right? Because that's my optimal shape. So it's going to be times 2.86, which is so, and then include a therefore statement. You guys all know what a Pringles container is. Like, I love how they include, like, the questions are like, they assume that everyone knows what things are, right?
So in this case, the optimal, we have to write the optimal dimensions of the r time the height.
Radius of this and a height of that. Yeah, so you say that the optimal dimensions of this can are a radius of this and a height of that. So a radius of 2.86 and a height of 5.72. Centimeter. Include your units, guys. Include your units. How about your last question? What do you want to do? Start with a volume. You know what? These are the easier kind of questions, right? Because if it comes to, especially we don't do that with a 3D, but especially with 2D, if it comes to saying like optimize the area if you're gonna use the wall as one of your sides, then it's gonna become more complicated because then it's not squishy, right? So, but we don't do that here, right? So these are the easier kind of questions. So the volume of a Pringles container is 1800 centimeter cubed. Find the optimal dimension of the container. So I'm gonna start with the volume. 2 pi r cubed. So what do you want to do? Divide by 2 pi. Divide by 2 pi. And then that will give you what? And then you have to cube root. Okay, and now what does that give you? So that's the radius. That's it.